Hello, gentlemen. Hello, Juraci. Hello, Gregory. How are you doing tonight?
Hi.
Wonderful. How about you?
I'm excited to have you tonight because this is going to be a very nice talk. And I want to emphasize on the name of this talk. This is not distributed tracing 101. This is not distributed tracing basics. This is distributed tracing deep dive. And the first question for you, Juraci, what it actually mean, what it means deep dive, and what can people expect from this talk tonight?
Right. So this is not a talk for people who don't know what distributed tracing is. This is a talk for people who've been struggling to implement distributed tracing in their production systems. So in this talk, I'm going to show you how to run a world-class production quality infrastructure for your distributed tracing components. So I'm going to show you how to run Jaeger on a variety of scenarios. And we are going to take a look as well on what should we watch when monitoring Jaeger. So, of course, people who have questions on distributed tracing in general or Jaeger or OpenTelemetry, they can ask those questions in the chat and we can try to address them. But the main focus of this talk is on running and managing a distributed tracing architecture for your infra.
Perfect. Red Hat is a well-known company for the software development tools, which helps us to run faster, debug faster, produce more efficient code, to trace faster, and some other things. But Contour, on the other hand, is well known for several products, for businesses, for medium-sized companies, small companies, or maybe even large businesses. Gregory, what's your expertise, what's your experience in distributed tracing, and what do you do in your company?
I develop some pipeline for distributed traces, so it's an important topic for me too, and I try to keep discussion going, so we can talk about some tools which are developing for several years, and we can discuss about this too, I think.
Nice, nice. So, Gregory and Juraci, are you ready for the talk? Should we start?
Absolutely, yeah. Let's go for it.
So, let's start, and this virtual area, yours. Watching the screen.
Wonderful. So welcome to Distributed Tracing Deep Dive once again. My name is Juraci Paixão Kröhling. I'm a software engineer at Red Hat, and I work on the Distributed Tracing team. I'm a maintainer on the Jaeger project, and I collaborate with the OpenTelemetry project. Now, I've been told that most of you know about Jaeger already, know about distributed tracing. So we start with a very fast demo, very quick, just to make sure that we're all on the same page here. We then discuss a little bit about Jaeger. So what are the main ways of deploying Jaeger and the architecture of its main component. And we discuss in a little bit more details about OpenTelemetry, which is a new project in this area. I'm going to show you how to deploy Jaeger on a variety of scenarios. So first, bare metal, and then on Kubernetes using Helm Charts. We then have a small intermezzo with a Q&A session, 5 to 10 minutes, roughly, when we move then to the second part of this session. So we have an interactive demo. We're going to play some game here, and then we're going to use Jaeger to tell us what we did during this game. Now we go back to seeing how we can deploy Jaeger, this time using operators for Kubernetes. We discussed then how to observe Jaeger, so how to what to look for in the logs and for the metrics as well. We discussed a little bit about the future of both Jaeger and OpenTelemetry, and we wrap it up with a Q&A session at the very, very end. At the end, we should have around 10 to 15 minutes for your questions. So again, if you have any questions that are not part of the topic of this talk, feel free to ask them anyway. So this is an advanced talk. I'm here to answer all your questions. All right, so as promised, let's get started with a very quick demo. So here on this directory, you can see all the binaries that you can find when you download Jaeger from a release on GitHub. So if you go to github.com/jaegertracing/Jaeger and you download a release, this is what you can expect from it. You get a binary with the agent, the collector, the ingester, the query, and then you get a binary with all in one of those components, except for the ingester. And then we have also an example application called Hot Rod, and that's what we're going to use today for the demo. So I'm going to start the Jaeger all-in-one here, all-in-one. Oops, I'm sorry, collector. Okay. Okay, agent, so agent tenant 1, and for the tenant 2. All right, now here we go. And then in our terminal, we start the example hot rod, and we start all the services in one. All right, so that's it. And we have here the main URL for the demo. And this is the one that I'm gonna share with you now here. All right, so you should be seeing the screen with hot rod example. So rod here means writes on demand. So whenever I click a button here, I have a car being dispatched to this client. So in this case, Rachel's floral designs. And I click another button, and another car is dispatched. But if I click quite a lot of times, I can see that the latency increases quite significantly. Now we can use Jaeger then to visualize what's going on for that specific click, for that specific action. And this is here a trace showing that transaction. And right in front of us is this, this operation here that is very long, right? So this one alone is taking 2.32 seconds out of a transaction that takes 2.67 seconds. Right, so we know that if we fix this one here, then the overall performance of our application is going to improve. So again, this is distributed tracing. This is Jaeger. This is each one of those lines here, each one of those operations is called a span. And this is the type of tracing that we are discussing today. So we're not talking about kernel tracing. We're not talking about strace, ptrace, ktrace, or things like that. We are talking about distributed tracing. Now, on to Jaeger. So Jaeger is a distributed tracing solution. It provides you with the client libraries, also known as the tracers, that collects data and send them to a backend component. It provides you with the backend components, and it provides you with a user interface to visualize this information and make sense of it. Now, when deploying Jaeger, you have two main options. So the first one is deploying it using an all-in-one architecture. So this is similar to the demo that we had before. On the left-hand side here, we have the business application. In our case, it was example hot rod. And within that application, we have a Jaeger client. In our case, it's a Go application, so it's part of the same binary. The Jaeger client sends data by default to a Jaeger agent running on the same machine. Now, machine here is machine is nowadays quite different, so it might be the same host, might be the same node, VM, bare metal, pod, or whatever you define as a host here. Now, in this scenario, we have the agent in the same process as the collector, so the same binary. But even though they are still part of the same process, the Jaeger agent sends data via gRPC to the collector. The collector then stores this information somewhere. In our example, it stored information in memory, but it could have been on Cassandra or Elasticsearch or something else. And the Jaeger UI then gets information from the same storage that the collector is using and displays that information to the end user. Now, this is nice and fast for local development and for demos like the one that we just had. But for production, you probably want something more robust. And one of the most popular architectures for that specific scenario is this one, where we have one agent per node. So again, the gray box, the bigger gray box here represents a host, and a host might be whatever you think it should be, so a VM, a bare metal, a pod. On the left-hand side, we still have our application with the Jaeger client embedded into that, and all of the applications on the same host, they send information to the same Jaeger agent. The Jaeger agent batches that information and sends that to a remote Jaeger collector. Now, the Jaeger collector here is in a different process than the Jaeger UI. And the reason is that we don't want a bug or some problem with the Jaeger UI to bring our Jaeger collector down, right? So the Jaeger collector is the critical piece of your infra. Of course, you can deploy it in a HA manner, so in a highly available manner. The collector itself is stateless, so you can just add more instances and adjust your load balancer. But still, you want that process or the collector to be isolated from everything else, including from the UI. That means that the collector has to store information in a permanent storage, perhaps Elasticsearch or Cassandra, and the Jaeger UI has to talk to the same data store to show data to users. All right, so if you've been using Jaeger, this is probably nothing really new, but I promise that from now on, we are going to talk more advanced topics. The first one is this one here. So it is important to understand if you're going to monitor Jaeger, if you're going to run it, it's important to understand how its main component works. And the basic thing for you to understand, or not the basic, but the most important thing to understand about Jaeger is how the collector is architected. So when it receives a span, the collector stores that span in a work queue. And from there are a couple of workers. Of course, the size of the queue and the number of workers is configurable. And a worker picks a span from the work queue and sends that span to the storage. That means that if our work queue is full, the collector can protect itself and just drop data and just not use all the information that it has there. It can just drop work. Again, this is for self-preservation. All right, so that's pretty much what I had on the theory behind Jaeger. And now the next topic is OpenTelemetry. But to talk about OpenTelemetry, we have to talk about a couple of projects before. The first one is OpenTracing. OpenTracing was a project aimed to be the standard for distributed tracing. One of the deliverables for OpenTracing was a specification saying what is a trace, what is a tracer, what is a span. The second deliverable was a document called the Semantic Conventions. Now that document, if I'm instrumenting a framework, if I'm a framework developer, if I'm developing like, I don't know, an HTTP middleware for Go, then I would check this document to know what types of tags I should be adding to the spans. Again, if I'm doing HTTP middleware, then I know that I have to store the HTTP URL in a tag named http.url, right? So that's dictated by the semantic conventions. And the third deliverable from OpenTracing was a set of APIs. An API for Java, one API for Go, Python, and so on and so forth. So this is a library that people consume, and they can use this API to instrument their application, both for instrumenting libraries and for instrumenting your business applications. Now, of course, each API has to feel like they belong to the language they were written for. So Java still has to feel like Java, and Go has to feel like Go. But it's also important for a Go developer to go to the same table with a Java developer and talk on the same terms and talk about the same things. So that's why the API has to feel like one API for all the languages. And then finally, as a kind of a side project for OpenTracing, were the instrumentation libraries. If you go to github.com/opentracing-contrib, then you find quite a lot of libraries that instrument frameworks that are quite popular. For instance, if you have an application built on, I don't know, based on Java servlets, then you are going to find a library that instruments the HTTP servlet layer for you. So it means that even though you don't instrument your code in any way, if you don't you don't do any manual instrumentation on your application, you still can find very valuable information being captured by the HTTP layer. Now, again, that was one example. There are quite a lot of instrumentation libraries for quite a lot of languages. So the final result is that you get a pretty good observability for your application just by using those libraries. Now, the second project that we have to talk about is OpenCensus. So OpenCensus was a project that aimed to be the single library for telemetry signals. One of the deliverables were a set of client libraries. So most of the popular languages had a client library provided by OpenCensus. So again, Java, Go, Python, Ruby, and so on and so forth. The second interesting part of OpenCensus was that it provided a backend service called OpenCensus Service. We're going to talk more in details about that in a couple of slides. The third aspect of OpenCensus is that it was not only for tracing, but it was also for metrics, and in the future, it would have been also for logs. And similar to OpenTracing, it also provided a set of instrumentation libraries, meaning that if you are using some popular frameworks, you can just use those libraries and get very good visibility of what your application is doing. Now, as you can imagine, quite a few of those items here are common between them, between OpenCensus and OpenTracing, and quite a few of those items are not really a match. So in some terms, they compete, and in some terms, they complement each other. And when the two projects got together, they decided to then form a new project. So unite and form a new project called OpenTelemetry. So OpenTelemetry today is it's a big project. It's the second most active project under the CNCF. CNCF here is the Cloud Native Computing Foundation. It basically inherited both aspects from both OpenTracing and OpenCensus, meaning it contains a specification, not only for tracing, but now also for metrics. It contains a semantic conventions document. It provides a set of APIs, and it provides a client library. So if you're not happy with a specific client library, you can implement your own. As long as it implements the proper API, you're fine. It provides also this backend service, which is now called OpenTelemetry Collector. And the focus for OpenTelemetry is not only for tracing. So tracing is the most advanced part of OpenTelemetry right now. But metrics is catching up quite quickly, and the idea is for the future to have also support for logs. Now, we've mentioned the OpenCensus service, and we talked about the OpenTelemetry Collector, and it is quite relevant for us here for this talk. So let's take a look at how it actually works. So the OpenTelemetry Collector is a pipeline for observability signals. It's basically a binary that you download and you run on your infra. It's built with the notion of pipelines. So you have data coming in at one end, and it's then exported in the other end. So receivers here, they can be active or passive. So typically, receivers are passive. So they open a port in your node, in your host, in your VM, and wait for data to come in, probably sent by the client libraries. They can also be active in that a receiver might then spawn a process and go somewhere to script some data, or perhaps to verify what is the current load for the machine that I'm running on, and what is the CPU, the memory and the CPU consumption, and so on and so forth. Right? But as long as once data gets at the beginning of this pipeline, then it flows down, and a processor can take a look at it. A processor has a decision to either change this data or block this data or release this data. And once data flows to the next level, then they reach exporters. And exporters, we can have multiple exporters at the same time. So it means that I can multiplex my data to send, to some internal solution and to some commercial vendor. When we're talking about tracing, a pipeline could look like this one here, right? So we have a couple of receivers, like Jaeger receiver, a OTLP, and OTLP here stands for Open Telemetry Protocol. We may have a Zipkin receiver as well. And then data may flow through processors, like the sampling processor that decides whether data should be kept or discarded. We may have a processor that enriches spans. For instance, if I'm running on Kubernetes, then I may enrich my data with the pod name and pod namespace that I'm running on. And we may have, and then data reaches the exporters. So I may be exporting data to my Jaeger instance, to some other OLTLP compatible endpoint, to Zipkin, and perhaps to some commercial vendor out there. All right, so in terms of architecture or deployment architecture, it is quite similar to the one that we've seen for Jaeger in production. So we have here on the same host, on the same node, we have on the left-hand side our application, so it's still the same that we had before. But instead of the Jaeger client, we now have the OpenTelemetry client. And the OpenTelemetry client then sends data to an agent on the local host on the same machine, which is now the OpenTelemetry collector. So the collector here is acting as an agent. And that OpenTelemetry collector then sends data to a remote Jaeger collector. And from there on, it's the same as we had before. Now, you might be wondering, why would I move from a Jaeger architecture to this one here if they are the same? And the answer is that they don't actually have to look like the same, right? So this is one of the use cases that you see now here, one collector per cluster, DC region. This is one of the use cases that is very hard to accomplish with Jaeger. So imagine that you have a couple of clusters, perhaps different data centers, perhaps even in a different region. And one of those clusters is quite established, so you have it running for a couple of years already. Everything is running fine, and you have one collector in there receiving data from your Jaeger agent, from your OpenTelemetry collector acting as an agent. And that collector in the middle, it then samples data at different rates depending on the cluster that it's running on. So for the well-established cluster, we may sample data as, 1% of the incoming requests are persisted, and then data reaches our Jaeger collector. For a new cluster, the one that is on the bottom part here, it is a new cluster, and perhaps we want to sample all the requests going in there, or perhaps 50% of them. So we have a different sampling rate for this one than we have for the well-established cluster. The final destination for all of this data is the same cluster of Jaeger collectors. So it means that we, SRE professionals, we can just go to one single place and see all the trace information for our whole collection of clusters, or for our whole infra. All right, so that's it on OpenTelemetry. So let's take a look and see what does it take to run Jaeger on bare metal. So one example you've seen already during the demo, I can just start the individual binaries, or the all-in-one binary. That's of course one way of doing that. And the second way of doing that, perhaps a more professional way, is by using something like systemd. So if you don't like systemd, that's fine. The same approach can be used with other solutions as well. So this here, if you know systemd, you know what this is. So this is a unit file, and in here we just specify what is the command that we use to start a process, and we specify here a configuration file for that. Right. So if I take a look at this file here, it contains only a couple of things. So the maximum amount of traces that I want to keep in memory, and the log level to set into debug. Everything else is quite standard for unit files. And perhaps the only different thing that we have here is this environment variable, which is required by the collector for us to set what is the storage type that we want to use. I know what you're thinking. So in-memory storage with the collector alone doesn't make sense, because we cannot get data out of the collector. But this is only for to show you how to do it with systemd files, right? So of course, in production, you would replace this with Cassandra, Elasticsearch, or whatever you use as your permanent storage. And the result is that we can just then invoke sudo system control start Jaeger collector. And if I do a status, so status I see that the process started 4 seconds ago. It's consuming 12 megabytes of memory and 44 milliseconds of CPU. All right, so we have here the configuration file that we specified in the unit, and systemd also provides us with the logs for the startup. Right, so we can see that the health check state changed to ready, so everything's working fine. All right, so this is it for the collector, and we can replicate this for all the other components, like the agent, for the ingester, for the query. For the agent, I'm going to do something slightly different. So I'm going to use something that is called an instantiated service for systemd. And an instantiated service is a service where we can use the same unit file for multiple instances, and we differentiate the instances based on what comes after the @ sign. So if we have here let's do it. So sudo system control start Jaeger agent @ let's say tenant1. Then it's trying to, so this is my instance name. Tenant1 is my instance name, and whatever I have, the percentage I is going to be replaced with tenant1. All right, so we have here in the command as start, we have the Jaeger agent using the configuration file for the tenant1. And this is how it looks like. All right, so we have here a set of ports. So the admin port, for instance, is on 14.271. And then we can just start the Jaeger agent for tenant2, and the configuration for it is this one. So it's pretty much the same, just bumps the port so that we don't have a clash, right? So 14.271 and 15.271. We can then get the status for both. So it's status, this. And we see that, this one here is taking 3.8 megabytes of memory, 10 milliseconds of CPU, and we can see that it indeed loaded the tenant2.yaml file for the tenant2 instance of the service. We can do the same for the tenant1. So again, under 5 megabytes of memory, so that's good, and very low CPU usage as well. So tenant1 and tenant1.service. All right. Good. So before I move on, let me make sure to stop those services. And Jaeger collector. All right, good. So everything is cleaned up, and we can continue with our presentation. All right. So the second thing that I wanted to show you is how to run, how to install Kubernetes, how to install Jaeger on Kubernetes using Helm Charts. I'm quite sure that you know about that, and Helm is a package manager for Kubernetes. Basically, we can use Helm Charts to install software that, Kubernetes applications, basically. The way that it works is, it is highly distributed, so the Jaeger team, we host a Helm chart or a set of Helm charts under our organization, and you have to add that repository manually to your local Helm installation. And you do that by doing Helm repo add, Jaeger tracing, or whatever name you want to give it, and the location of the Helm charts. And after it's installed, you can provision a new Jaeger instance by doing Helm upgrade -i Jaeger, and then what is the name of the Helm chart that you want to install. And that's what we're going to do right now. Right, so let me go back to my code editor, open the Helm directory, and I'm going to copy the same comments that I had there. Well, I can copy this first one here as well, but it's a no-op because I do have this one here already. And this one here is the one that is going to install our Jaeger instance. So we can do a kube control get pods -w to watch it, and we see that things are happening. So don't worry if you see this crash loop back off here and this error. Those are fine. They're actually kind of expected. And the reason is the default configuration for the Helm chart for Jaeger will try to provision a Cassandra cluster. So 3 nodes of Cassandra, and both the query and the collector, they need Cassandra to be up and running before they can be up and running themselves. So they're going to fail until Cassandra is ready, and when Cassandra is ready, they then succeed. So we're going to see 5 to 6 restarts of both the query and the collector until they eventually work. It takes some time, so as you can imagine, so 3 Cassandra instances, they take some time to get started. And after Cassandra is ready, then we are going to run, or it is going to run automatically here, the create schema for Jaeger. So there is a batch job that is waiting for Cassandra to be ready as well, that we will actually create our tables and all the things that Jaeger needs from Cassandra. Again, it is taking, 5 minutes perhaps, and while it runs, we can then go ahead and see if we have any questions already. So let me go back here. Okay, so I'm now ready for your first round of questions.
Thank you for the first part, but I see that there are no questions in the chat, but I can ask you my own questions if you agree. Can I ask you something?
Go ahead.
Okay.
Sure, absolutely. Go ahead.
Okay. We are building some pipeline with distributed traces in our company, so I know a dozen of stories with some fails and success stories, and maybe you can share some things about these fails when you build pipelines or something else with another tools which you have.
I can probably do something slightly better than share fail stories. I can probably share some alternate architectures for people to construct their pipelines. Would that work?
Yeah, sure.
Sure, good. All right, so let me share you then. Sorry. This is something we've seen. All right. So what people have been doing in production today, well, most people are deploying things on Kubernetes, at least for greenfield applications, and perhaps not for all applications, but for the typical workload. And what people have been doing there is adding agents to the same pod as their application. All right. So in this case here, what we have is for the same pod, we have on one container with our application and the Jaeger client. So this is the example hot rod binary that we've seen before. And on the same pod, then we have a Jaeger agent. Now again, whenever I say now Jaeger agent, I also mean the option that you can use Open Telemetry collector there. Right? So both processes are very lightweight, and you can already replace them. The idea here is that if one Jaeger agent dies, it's okay because it's only for one pod. The overhead is there, of course, but it's 5 megabytes, so I think it's a good trade-off. Another architecture that people have been using is something like this, a multi-tenant Jaeger with one infra per tenant. So this is a soft tenancy, as we call it. Basically, for each tenant that you have, you replicate your infra. So you can use a provisioning tool to make sure that each tenant has one infra, right? So by infra, I mean from the application up to the storage. So tenant 1 has one Jaeger client and one application. Tenant 1 has one Jaeger agent. Tenant 1 has one Jaeger collector for it, and a storage as well, a storage cluster. Now, because the storage is the biggest problem here, so if you managed Elasticsearch or Cassandra before, then you know that it's quite hard to manage one. So, and imagine like hundreds of tenants, so it's quite hard. So one option that, one variant of that architecture is this one here. So in this case, we share the storage or the Elasticsearch cluster or Cassandra cluster, and we only split the tenants per index. So perhaps the tenant 1 uses a specific index for Elasticsearch, and a tenant 2 uses another index prefix. You still have one instance of Jaeger per tenant. And I think today it is quite acceptable because Jaeger itself is really, really lightweight. Right? So you've seen that the collector takes, I don't know, it was taking less than 10 megabytes of memory. The agent also takes less than 5 megabytes, so it's really lightweight. And yeah, so we haven't talked about streaming yet, and I think it is another pattern of what people have been doing out there. One of the storage mechanisms for the collector is actually Kafka. But Kafka, of course, it's not a storage mechanism per se. It's a message queue mechanism, or a queue that runs somewhere. So that's where the Jaeger ingester fits in. So the Jaeger collector can send data to Kafka. The Jaeger ingester reads that information whenever it arrives at Kafka, and then writes to some storage. The advantage of such an architecture are twofold. So first, it allows our whole infra to be even more scalable, because you can then just, if our storage cannot keep up with the pace of the Jaeger collector, then we can have an external buffer, and this buffer is then called Kafka. And Kafka is something that people have already, or not all the time, of course, but it is something that is very common on today's workloads. So it's not unreasonable to expect people to have Kafka in there. And the second reason to use something like that is that people might want to have their own processing pipelines. So Kafka may have ingester might be only one of the consumers of the data reaching to Kafka. You may have your own component that reads the same spans from Kafka and do some post-processing on your own. Perhaps you have some business analytics that you want to feed information to, or use cases like that. Was it helpful? Did that answer part of your question, or?
I have another question, and talk about briefly about performance. Our audience love performance stories. How do you scale Jaeger collectors in such cases? Is it topics in Kafka or something else? How to scale it?
Yeah, so the Jaeger collector is really stateless. So you can just add more instances in there and they will just start working. So they don't need anything other than the configuration file. Of course, it's not 100% stateless because data reaches in and then they have to be sent out. But they're mostly, you can just add more instances and it works. Now, the tricky part is then load balancing that. And that's another advantage of having a very high number of agents out there, one per application, one per instance of the application. And the reason is that the communication between the agent and the collector is via gRPC, which means that it's a long-lived connection. So that agent will, whenever possible, talk to the same collector because, that's one connection being open, so I don't have to multiplex between the connections. I don't have to context switch, right? So that's more performatic. So if you have hundreds of agents, then the chances are that the balance on the backend would be good. Whereas if you have only 2 agents and 10 collectors, then 8 of those collectors are going to be idle, and 2 of them will be with very high load. So the tip here is to is whenever possible to have more agents and collectors in there. So that's how you scale collectors, yeah.
Also, performance and scaling capabilities depend on chosen backend storage. You mentioned in memory, Cassandra, Elasticsearch, maybe something else. What can you say about throughput of these pipelines?
Yeah. It really depends on your setup. I know I hate answers like that, but it really depends on how you configure your Elasticsearch and your Cassandra. And the other variant here is that the size of the spans, they depend on your application. So if you have an application that is storing a lot of logs within the spans, then that span is quite heavyweight. And that's a lot of data within that span. Whereas if you're not storing any logs, you are just storing metadata, like when did it start, when did it end, a couple of tags, then they're very lightweight, then the requirements are quite different. Now, we've seen Elasticsearch being used out there on the gigabytes of data per day. We've seen cases with hundreds of thousands of, sorry, not hundreds, but tens of thousands of spans per second. So it's really up to your Cassandra or Elasticsearch configuration. Jaeger Collector itself is really fast. We're going to see on the metrics on observing Jaeger that if you have performance issues, then it's very likely that your storage is a bottleneck. It's very rarely a problem with Jaeger itself. On the client side, so the question on performance, I'm going to advance myself and talk now about the performance on the client side, on the client libraries, on the impact of the performance of the client. There was a very nice work last year done in this front. And the answer for that is basically that the tracing clients, they do cost something. So you are paying some performance penalty when using tracing. But for the most cases, for the most part, it is acceptable because the performance hit is so small that one downstream call that you make to another HTTP service is already, more than the overhead that you have from the tracing library.
Okay, we have a first question in the chat. I'll
Sure.
ask you. Anton asks you, is it possible to use only Kafka and in-memory storage for spans? He doesn't like to serving Elastic and Cassandra because it's complex systems.
Right. Yeah. So in memory, it doesn't make much sense with anything else than all-in-one. And the reason is you have the Jaeger collector binary, and then you have the Jaeger UI or the Jaeger query binary. And if you have two different binaries, they have to share the same memory space. And if they're not part of the same processes, if they're even running on different pods, on different nodes, then they cannot share that. The only way to have in-memory storage is with the all-in-one. And all-in-one, unfortunately, cannot use the ingester for the same reasons, or Kafka for the same reasons. So you really need to have, like for production purposes, you really need a permanent storage, as much as you don't like Elasticsearch or Cassandra. I can feel your pain. I really wish every single day that we had better solutions out there for the storage, but right now it is the best we can do. And saying that, you are more than welcome to join us in the community and have a discussion about storage, because it's a never-ending discussion, and we are always eager to hear other opinions and other ideas.
I have a little story about storage engine. Once upon a time, we had started with Cassandra as a storage engine in our pipeline, but scaling have turned out to be very expensive for us when we count of traces spans have reached, if I understood our measurement right, about 1 million per second. And we need to think hard about what we are doing, and we switched from Cassandra engine to ClickHouse, and ClickHouse helped us reduce costs by at least 3 times comparison with Cassandra.
Cassandra, yeah, that's true. So quite a lot of people are using different storages. I encourage you to take a look at KubeCon videos from EU this year. So they're all on YouTube. You can. There's one specific talk mentioning how they export this data from Jaeger to some external service, and the way that people do to deal with the limitation that we only support a few storage mechanisms is to build their own like Jaeger distribution. So they can just create their own binary. So it requires some knowledge about Go development, but then you can write your own storage, and it's very performatic. So it is also a solution. Now, stay tuned. We have some news about that, and I hope to be able to talk about that in more details in one of the few slides about the future. But yeah. All right.
Okay,
So
let's,
if you have, sure. Go ahead.
Sure. I think we should to go further, and my question can wait something more.
All right. So if you have any other questions,
at the
not
end
only you, but
of the talk.
yeah.
Okay.
So if you have any other
Let's-
questions, not only you, but from the audience, write them down, and we have another Q&A session at the end. Right. So, all right.
Yeah.
So let's move forward. So let me go back one slide here. So back to the Q&A. Before we went to the Q&A, we were talking about provisioning Jaeger with Helm Charts, and let's just take a look and see how it goes. So what we have here, we have our Jaeger agent and the 3 Cassandras that I promised, plus the collector and the query. They're all running. They're all fine. It took 5 restarts for the query and the collector to eventually reach a stable state, right? So that's what I wanted to show you. Before moving to the demo, let me stop or delete my Minikube setup. And I'm creating another one here because we're gonna need in the future. But for now, we have how about an interactive demo, right? So for this demo here, let me open a browser window. So for this demo here, we have a service mesh arena. So this is a demo that was developed by someone in the Kiali team. So Kiali is a service mesh observability tool. Don't worry about service meshes. We're not talking about service meshes today. This demo, though, is quite useful to tracing as well. So you're going to see a link to this application and to the Jaeger UI in the Telegram channel. Something is all right here. So let me reload and perhaps center the ball. All right, good. Something is happening here. I don't really know what it is. I think people might be clicking on randomize ball, and that's absolutely fine. The way that it works here is you can click on a player and you can type in here your name, and you can just click shoot. Now, the players are going to go over the ball, or they're going to run to the ball, and the only thing that we can do is shoot the ball. Now, if we can get to the ball, right? So it's really fun. All right, so Blanchard. All right, so you should have the link to this application there on Telegram, so you can just click a player, type in your name, and click shoot. Right? Let me try here this one. So here, yeah. So I'm going to give you a couple of minutes to play around, and let's see if we can get a goal here scored. I'm playing as well, right? So I'm also trying to score a goal. All right, so I think that's enough activity for this field. So we can try and take a look on Jaeger to see what's going on in here, right? So this is our Jaeger UI running on an OpenShift cluster that I started earlier today, and here we have all the services that are serving this application. Let me see. Yeah. So what we can do here is on the UI service, for instance, we can then list all the operations happen there. So we've seen. Let's take a look at random ball. Right. So we had quite a lot of people clicking on random ball. So like this one here, randomized ball position. And if we open one of those traces here, we can see that we can see quite a lot of information about that, right? We can go back to the Jaeger UI here. We can go to the ball service and find traces. and we get all the information. So let's try to see if we get some goals. A minute ago, someone scored a goal, and that's wonderful. Let's see. So that was Lisa. So Lisa scored a goal, and Lisa was playing with Blanchett. So nice. That was the only goal that we had for the last hour. So congratulations on scoring a goal. And all right. So yeah. So that's Jaeger. This is a, so as you can see here in this application, it's not telling us who is actually scoring the goal, only the player, right? So it kind of shows us that even though we don't actually thought about adding this information to our UI, when we are maintaining this application, when we are working as a reliability engineer for this application, we can still use distributed tracing tools to expose more information than we originally planned for. All right, so thank you for playing. I hope you had some fun in here, and I hope that you can still keep playing until the end of the session here, or we can go back and watch the remaining of the session. All right, so let's continue with on more serious topics, and now it's time to see how we can deploy Jaeger on Kubernetes using an operator. And I think the first question that we have to answer is, what exactly is an operator? So if you go to operatorframework.io/what, you see a definition similar to this one here. So an operator represents human operational knowledge in software to reliably manage an application. There are methods of packaging, deploying, and managing a Kubernetes application. Now, Kubernetes application here is something that probably requires some explanation. So when it says a Kubernetes application, what it means is I have my business application somewhere. It is like a binary or a jar file, and I package this application in a container, and I then create quite a lot of other resources like YAML files typically when we're talking about Kubernetes, and they all they all are connected, and they all form a Kubernetes application. So the collection of a deployment, a service, an ingress, config maps, and so on and so forth, they all form a Kubernetes application. So an operator then, translating this into other words, an operator is a piece of software that knows how to operate or how to package, deploy, and maintain our business applications in the context of Kubernetes. So in concrete terms for the Jaeger operator, we are talking about provisioning Jaeger instances. We are talking about injecting sidecars into business applications. So you know what sidecars are. So sidecars are a second container to your pod. So you have your business application as a deployment for Kubernetes, and that deployment then generates a pod, right, at runtime. And within that pod, we have a container with our application, and we may have a second container, which is a sidecar. Now, you probably do not want your developers to care about sidecars at all. You don't want them to know how to add a sidecar for Jaeger. That's the role of the operator, of the Kubernetes operator, be it a human or an automated one. In the case of the Jaeger operator, it knows how to inject those sidecars into your business applications. You can just add an annotation to your deployment saying, I want a sidecar to be injected for this deployment, and the Jaeger operator is going to do that for you. And finally, the Jaeger operator can also upgrade your Jaeger instances. So if you have like 10 Jaeger instances in your Kubernetes cluster, the Jaeger operator is able to upgrade them whenever it sees an upgrade or the need for an upgrade. So typically the Jaeger operator follows the same versioning as the Jaeger core. So if Jaeger is now on version 120, then it means that we have a Jaeger operator 120 as well. And then we had a 121 release for Jaeger. So whenever I upgrade my operator from 120 to 121, the operator is going to take a look at all my Jaeger instances in my cluster, is going to find all the 120s in there, and it's going to upgrade one by one to 121. It knows how to upgrade from 120 to 121 because we developers of the Jaeger operator, we go over the change log for Jaeger from, for the version 121, and then we see what needs to be done to bring a 120 instance to a 121. The final result is that you, the person who is managing a cluster, the person who is using Jaeger, you don't have to follow the versions one by one and read the change logs for all of them. We are doing that for you, and we are encoding all the changes in the operator for you. Of course, some changes might not be possible to automate, and luckily enough, we've been able to get around this with all the changes so far. The reason is that Jaeger is very good at backwards compatibility. So data changes are really rare. I don't remember seeing one in the last, couple of years. So there's no need to have a downtime for your Jaeger instance, right? So the Jaeger operator can just change the configuration, and Kubernetes is going to take care of reconciling that to the final state. Now I've mentioned provisioning Jaeger instances, and it's not very clear perhaps what it actually means. And what it means is when I'm provisioning a Jaeger instance, I'm provisioning deployments, services, config maps, horizontal pod, autoscalers, service accounts, cron jobs, ingresses, Elasticsearches, Kafkas, and so on and so forth. Right? So those are things that are typically involved when creating one Jaeger instance on Kubernetes. So that's why it's good to have an operator there to manage all this complexity for you. All right, so enough theory. So let's take a look at how we can actually install the Jaeger operator in our cluster. So you might remember that I started a Minikube cluster right before we left for the interactive demo for the soccer game. And my Minikube is ready. So let me open here the operator demo and the README file with all the comments that we have. All right, so the first step is to run this shell script that operator. And while it runs, I'm going to show you what it actually does. So we have, the first step is we create a namespace. Let me do a kubectl get deployments for namespace observability watch. Right, so we are going to see when the operator gets started. So what we did in that script was we first created a namespace called observability, and then we created a set of resources. So the first one was something called a CRD. So a CRD is a custom resource definition. So we can register custom types on our Kubernetes cluster that instructs it what a Jaeger type looks like, and this CRD is exactly that. It's like the schema definition for a Jaeger type on our Kubernetes cluster. We also install a service account, a role, and a role binding. Those are for to make sure that our Jaeger operator is not doing something that it's not supposed to do. Right. So those are security aspects. And then we have an operator YAML file. This is a plain Kubernetes deployment, nothing really fancy in that. The operator itself is just an application that knows how to talk to Kubernetes, basically. All right, once it is done, then we have a deployment like this one, which is already running. So it took about 21 seconds to stabilize. And then once it is ready, we can then install our first Jaeger instance in there. So let me run this one. So when I run a kubectl apply on namespace observability and the file simples, then Kubernetes tells me that jaeger.jaegertracing.io/simples is created. Now, how does it look like? So simples, that's all that it takes for us to get our first instance of Jaeger running on Kubernetes with the operator. So we just specify the kind and API version, regular Kubernetes stuff, and then we specify a name for it. Right? So our name is the simples. What we can do now is we can do a kubectl get Jaegers from the namespace observability. And we have it here, like we have a simples Jaeger, version 121, strategy only one, and in-memory storage. Right, so we haven't specified the storage mechanism or the strategy, and basically the Jaeger operator made some guesses based on information that we've sent, some educated guesses, of course. The only storage mechanism that doesn't require configuration is the in-memory storage, and the only strategy that can be used with in-memory storage is the all-in-one. So we don't have to specify anything at all if all that we need is a in-memory all-in-one instance. But that's, of course, not something that we want to do for production, so we can just install an Elasticsearch instance. Let me show you what it does, but we can also watch the progress of it. So kubectl get the stateful sets from the namespace Elasticsearch watch. All right. So kubectl create namespace Elasticsearch. So that's our install ES shell script. And the only other thing that it does is it loads a YAML file from the Jaeger Operator repository, GitHub repository, and this is actually used for our E2E test. So please don't use this one. If you can look for or do some research about a suitable Elasticsearch operator, if you cannot find one that suits you, then take a look at the Helm charts. Even if you cannot find one after that, then you're free to look at this one here that we have for our E2E tests and adapt to your usage. But yeah, so it's not what we really support for production. All right, so Elasticsearch is ready here. It took about a minute to be provisioned. So we can now provision a production quality installation of Jaeger in there. And again, we have we just applied a YAML file, and I'm going to show you how it looks like. But before, let's get all the Jaegers, that are running in there. So simple prod is this one. So we have the same API version and kind that we had before. We have a different name, but what is interesting here is this set of lines here. So we specified, we created a specification for this Jaeger instance, and we told it that we want a production strategy with a Elasticsearch storage type, and this is the URL for the Elasticsearch. So this is running on, so this is a service running on the Elasticsearch namespace, and this is a stateful set Elasticsearch, right? So this is in our Kubernetes cluster as well. Once it's done, so it took about 25 seconds to provision, and we can now, let me clean the screen here so it's simpler to take a look. So we have now two instances, one simple prod and one simples, and we can see different strategies, different storage. And if we want to take a look and see what it actually does, what are the effects on our infra, what we can do is we can, instead of getting Jaegers and -watch, we can do a get, I don't know, services. And then we see all the services that the Jaeger operator created when we asked for a Jaeger instance. So it created a simplest query, simplest collector headless, simplest collector, simplest agent. So those are all services related to the simplest instance of Jaeger that we asked. Then simple prod query, simple prod collector headless, simple prod collector, and so on and so forth. Right, we can do the same for ingresses, and this is interesting, ingress, and we see two ingresses as well, so one for each instance, so simple and simple. I don't actually have an ingress controller on my on my Minikube running locally, so I don't actually have an address here. And this is important because if I want to open the Jaeger UI, then I would have to do a port forward. Right, so I can actually do that now and do a port forward, and then run on this one here. Let me open another window and share it with you here. Right, so if I reload, I see Jaeger tracing itself. So it's a simple prod.observability, and this is the instance that we are just forwarding the port from Minikube, or from the Kubernetes cluster to our local machine. Right? So that's because I don't have an ingress controller in there. All right, so we've seen how to install Jaeger, how to provision Jaeger on a simple Jaeger instance and a production quality Jaeger instance. And I think it's now time for us to talk about observing Jaeger. So the first basic way of observing Jaeger is, of course, with the logs, and I'm not going to spend thoughts on that because you're all quite used to watching logs already. And for the metrics, what we can do is, so each component of Jaeger comes with a admin port and metrics available on /metrics. So for the simple prod that we have in our Kubernetes cluster, we can just do a port forward like this one, oops, and load it like this. /metrics, let me share the screen with you. All right, so it is on my local port 14.2.6.2.9 /metrics, and we have here a bunch of metrics. So go over them, take your time and analyze them and see what are the ones that make sense to you. I do have a collection of metrics that I wanted to share with you as really important. The first one and the most critical one is spans dropped. Right, so if you remember from the first slides that we've seen today, the collector has a work queue and a number of workers. And when we have more work coming in than the backend storage is able to process, then we start dropping data, we start dropping work. And this metric here, this data point, tracks that. So if we start having spans dropped, then we probably want to take a look at what's going on. Having spans dropped is not bad per se. It just means that the Jaeger collector is trying to preserve itself from consuming too much memory. It is the limit that we set for the Jaeger operator. So if you are constantly having spans dropped and your memory consumption is still very low, so increase the number of items that you can process on the queue. So tune your Jaeger to increase the queue size. Now, when you have a spans dropped, then it's very likely that your save latency is also on the high buckets, meaning that your backend storage is not able to keep up with Jaeger. Two other things that you can take a look at are the queue length and queue capacity. So one is the configuration that is specified for Jaeger, and the other one is the current state of the queue. So you can use a relation of the two to derive what is, if your instance is sane. So if it is not in a good ratio, then you probably want to create an alert or take a look by to see what's going on in there. Again, generally they all relate to the save latency being very high, right? So if you see signs of things starting to get slow, then check the save latency. And then finally, the other metric that I recommend taking a look, perhaps even adding to some dashboard, is the span saved by service. So you can group them by the services that you care about. They can also be aggregated by the outcome, so success or error. And if you don't see spans, or if the rate of change for a specific service on a specific outcome, like success, is not changing for the 5 minutes, for the past 5 minutes, then it means that either your instrumentation is broken for that application, or the service is really down, right? So it's you can use that as a in your dashboard as well. All right. So before moving to the final Q&A part for this session, I would like to talk a little bit about the future. What is very imminent right now is the V1, or the general availability of OpenTelemetry. Once it is out there, we plan to rebase Jaeger on OpenTelemetry collector. What it means is that Jaeger collector V2, or the Jaeger V2, is going to be based, or most likely going to be based on the OpenTelemetry collector infra. Right? So it really pays off to read and to learn about the OpenTelemetry collector, how it's configured, how you can run it in production as well. It is something that we are thinking about very seriously about doing with Jaeger, is to move to the same base as the OpenTelemetry collector. What is in our roadmap as well is a more native multi-tenancy. So if you remember our talk in the middle of the session, we had a couple of slides on multi-tenant architectures, and in both of them we have one tenant per infra, meaning one Jaeger instance per tenant, and we want to change that. We want Jaeger to be multi-tenant itself, right? So it is something on the roadmap and should be coming for the V2 or perhaps a minor version after V2. And then once we have Jaeger V2, we should probably also work on the Jaeger Operator V2. The idea is that the Jaeger Operator V2 should be able to migrate your Jaeger V1 instance to Jaeger V2. It's not a promise. It all depends on several factors, but at this moment, we don't see why it wouldn't be possible. So we want this transition from V1 to V2 to be as easy to manage as possible, especially if you are using the Jaeger Operator. All right, so that said, I'm now ready for your final questions. And again, it doesn't have to be on the topics that we had today. It can be general questions on Jaeger, OpenTelemetry, or distributed tracing in general. All right,
Juraci, thank you so much. And it seems that QA section will start it in the discussion zone as well.
All right, cool, wonderful. All right, so thank you all for listening, and I hope you learned a few things today, and hope to see you soon again.
Nice. Thanks for the talk. I have technical team. If we have some spare time till the next block or not. Oh, still, Gregory, I was misled by your question, by your phrase that we don't have enough time for these for the questions and answers. Oh, but if you allow me to do that, the final question from my side: you work for such a huge company, and you very involved into open source community. Can you tell a little bit more about policies of the Red Hat company concerning the open source projects, pet projects, and your personal involvement into some other project? Maybe if you have, I'm a sportsman, for example. I have a pet project in the area of skiing. Do you have any kind of hobbies, pet projects?
Yeah, so the first part of the question about Red Hat, right? So Red Hat is, everything that we do at Red Hat is open source. So everything that you can get from Red Hat is open source. The way that we make money is by providing a phone number for people to call at 2 a.m. when they need help, right? So that's, of course, it's not as simple as that. We have other ways as well to monetize, but that's the main reason why people pay us money for. That means that everything that we have a policy of upstream first. So everything that I've shown you is, of course, open source and is running on Minikube. So it's not running on Red Hat products, OpenShift and so on. So it means that we work very closely in creating technology first, and then packaging that in enterprise packaging. So the bits are the same, the source code is the same that we provide. It's just, we have some quality engineering happening and testing that, and documentation writing and that kind of stuff.
Oh, sorry.
That kind of links.
To interrupt you.
Right. Sure, yeah.
Sorry, the time is over. I have to say that's almost it. Sorry about that. That's very important information. And I believe you can share that in the discussion zone where we're going right now. Thank you so much. Have a good night and see you next time. That was DevOps Conference. See you.
See you. Bye-bye.
See you too.